Welcome back to number 3 in your covalent bonding lessons. I know these get you excited, but try to contain yourselves. So far we have talked about, obviously, covalent bonding. We have talked about how it is a sharing of electrons. Big thing to know there. We've talked about how it is either two nonmetals or a nonmetal and hydrogen, because hydrogen is just that special guy. The end product of a covalent bond is actually called a molecule. The word molecule is misused a lot. I do it myself. Technically, a molecule or a molecular compound has to be something that is covalently bonding. So NaCl is not technically a molecular compound. It is an ionic compound, which is different. So it is a really, really misused term, but understand that when you see molecule or molecular, it is supposed to be referring to something that is a covalently bonded duo. The other thing we see with covalent bonding is we see diatomic molecules. We talked about diatomics earlier in the year. That's two of the same atom that are always joined together. There are actually 7 elements on the periodic table that will always form diatomics. You will never see them by themselves. They'll either be bound to themselves as a diatomic or they'll be bound to something else. For example, oxygen. You guys know oxygen is O2. Okay? You are never going to see O by itself. Now, you can have oxygen alone and bound to something else, like an H2O, but it's not by itself. Okay, if it's not bound to something else, it will be O2. So the 7 diatomics that you need to know are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And I know what you're thinking. You're thinking, memory trick would be nice here, Miss Michael. Don't worry, I gotcha. If we look at the world's greatest cheat sheet, otherwise known as the periodic table, there is a really easy way to remember the 7 diatomic molecules. 7 is the key here. Now, first of all, you just have to remember hydrogen. There's not much I can do to help you with that one. You just have to remember him. The other ones, the other diatomic molecules, are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And if you are quite crafty, you will realize that that makes a number 7. Okay? Then there's also hydrogen. But the rest of them make the number 7. I'll do you one better. Look where it starts. That 7 starts with element number 7. Okay, so the 7 starts with element number 7, goes over to those with 7 valence electrons. Yeah, there's a lot of ways to remember that there are 7. So it's hydrogen plus those guys. You need to memorize that. Now, the big topic for today is naming. Okay, naming with ionics, if you remember, was quite complicated. That's when you had to do the split and figure out, is it iron 2, is it iron 3, what's the charges? Yeah, we're not doing any of that. This is so much easier, okay? The only thing you have to do to be able to name covalents is you have to know prefixes. So, the prefixes you need to know, 1 is mono. I bet you already knew that one. 2 is di. Bet you already knew that one. 3 is tri. Bet you knew that one. Now we're delving kind of close to geometry land. 4 is not quad. I know you want it to be quad, but 4 is tetra, like tetrahedral. Okay? Then geometry is actually helpful. 5-sided shape, you guys know, is a pentagon. So the prefix for 5 is penta. 6 is hexa. Again, your geometry comes in handy. 7 is one you may not already know. 7 is hepta. 8, I guarantee you know because you drive or you want to drive. That is octa. 9 is nana, as in nonagon. And 10 is deca. So do you have to memorize 10 things? Yes. But I'm going to bet you already knew 1, 2, and 3. I'm going to bet you knew 5. I'm going to bet you know 6. I'm going to bet you knew 8. You probably knew 10 as well. So that leaves you with like 3 you have to learn. So here is the way that we name covalent compounds. Again, we are sticking with binomials, okay? So the things that we are going to be naming are going to be made up of 2 different elements. All right, that makes our lives easier. You can get in the hard stuff later on when you get in college. So for the first element, okay, you are going to add the prefix that matches the subscript. Now, the only exception with this is on the first one, we don't use mono. All right, and you actually already know this whether or not you realize it or not. Okay, for example, if I ask you the name of that, you're going to say, oh, that's carbon dioxide. That's correct. It's not monocarbon dioxide. We know that. So the only thing that's weird, we add the prefix, but we don't do mono if it's one. The other thing that I don't get real fussy about this, but you need to know, is we tend to avoid the AA, OO, or AO double vowels. So if you do this for me and you do the vowels together, I don't care. For example, if there's 4 oxygens somewhere and you say tetraoxide, that works for me. I got no problem with that. Technically, though, it's not. Technically, it becomes tetroxide. Okay, but again, that's a nitpicky thing. So, first word, you're going to add the prefix. Then we get to the second element. For the second element, we're going to, wait for it, add the prefix. Seriously, that's all there is to this. And then just like you did with bionics, they end in IDE. So going back to this guy again, you name the first one carbon. We don't put mono, okay, because he's just by himself. And then this is dioxide. Change the ending to IDE, put the prefix on it. So I know you're waiting for the catch. There's not one. When we're looking at naming, and you've got a couple examples in your PowerPoint, S2Cl2, add the prefix, disulfur, okay, and then that second part, di, but this time it's not chlorine, it's chloride, disulfur dichloride. If we did SO3, the first one is mono, but remember we don't add mono to the first one, so this becomes sulfur. Then the second part, there's 3 of them, so tri, and then I've got to add the IDE, trioxide. Okay, you want the big guys? Make you sound really smart? Look at P4O10. Ooh. Add your prefix, tetra, phosphorus. Ooh, big word. And now we're to that decaoxide, because there's 10 of them. Technically, it is decoxide. Okay, seriously, all you have to do to name covalents. It's so simple. Okay, I know you're waiting for the catch. There's not one, because going the other way is even easier. Let's say I give you a name, and I say I want the formula for carbon tetrachloride. On ionics, you had to think of charges and crisscross and really focus. Yeah, no, okay? There's 1 carbon, there's 4 chlorines. So this formula is CCl4. Bam. That's it. Okay? If I give you dinitrogen monoxide, okay, or monooxide, same thing, we just eliminate the double vowels. There's nitrogen and oxygen, and it's dinitrogen, so there's 2 of those. Monooxide, there's 1 of those. The formula is N2O. Seriously, that is all you're doing. Okay? There are 4 elements that your SOL expects you to know common names for. One of which, oops, didn't mean to write an H yet, one of which is dihydrogen monoxide. You are absolutely 100% expected to know what dihydrogen monoxide is. Okay, what is it? It's H2O, otherwise known as water. So your SOL expects to be able to say water and have you know they're talking about H2O. I have faith in you. Another one they're expecting you to know the common name for is NH3. Okay, some of you may know this already, some of you might not, but NH3 is ammonia. So you are expected to know ammonia is NH3. The third one is CH4, okay, carbon tetrahydride, but nobody calls it that. They call it methane. Okay, you are expected to know that one. And then the last one your SOL expects you to know is HCl. HCl can actually be named a couple different ways. By our rules, it would be hydrogen monochloride, but it is really hydrochloric acid. We are not really learning all the rules of naming acids in this class, and trust me, there are a lot of rules of why this is hydrochloric and not hydrochlorous. We don't get into that level, so for us, you just need to know HCl is hydrochloric acid. That is your covalent naming. I'll be back in another video talking about shapes.